Hey guys, so welcome to another one of my little tutorial videos, and today I'm going to be talking about timers. And this first part of this video, we're going to go over to the basic operation of a timer, how to get it set up and how to get it counting, and from there we'll move on to other videos where we'll progress onto PWM, output compare, input capture mode, which is a very useful mode, and well, let's get it going then. So to get a visual of what we're going to be doing here, I'm going to be using timer 4 just for this example. Again, you can use any timer you want because as basic timers, most of them can be used as a basic timer. And from here you can see that all timers basically have 4 channels. You can see here they all have 4 channels. I'm going to be using timer 4, channel 4, and we're going to be using, well, we're not going to be actually, in the beginning, we're not going to really use a channel. We're just going to get it counting up. But once we get into the PWM and all this other stuff, I'll be using channel 4. And that's going to be on port B. Let's get the output. Here we go. On port B9. Okay. So that's how you're going to... that's what the hardware part's gonna look like. We're gonna use channel 4 on timer 4 on port B9. Okay. So timers are a very extensive subject. The datasheet alone has over 100 pages just on the timers, just because there's so many of them. Let's close this up. Here we go. You have basic timers. You have your real time clock, which doesn't really count as a timer, but I mean it does have to do with time. So, but anyways, actual timer peripherals are just these 3: your advanced timers, your general purpose timer, and your basic timer. The basic timer doesn't do much. I mean, it is very useful just as a counting and stuff like that. But the general purpose timers and the advanced timers have a lot more features. As you can see here, capture modes, output modes, PWM, and this is all the stuff that everybody's asking about. So I'm going to be using timer 4, so we'll look at this section here, and let's look at the main features. It's telling us that it's an up down up down auto reload counter. Okay, so that means we don't have to concern ourselves with reloading it or restarting it, because it does it by itself. It has 4 channels, like I told you, for input capture, output, output compare, PWM, and 1 pulse mode. Now these 4 modes, 4 channels, it does not mean channel 1 is this, channel 2 is that, channel 3, channel 4. No, each channel can do any of these. So channel 1 can do that, that. Same thing for channel 2, 3, and 4. They can all do everything. Okay. When you first kind of look at this, you kind of get the idea that there's 4 channels. So channel 1, channel 2, channel 3, channel 4. But no, it's every channel can do all of these. Obviously not at the same time. You can only set it up as one of these at one time, but it can do any of these. Okay. What else can we tell you about the timers? So yeah, so if I could give I guess a brief description of what you would use these for. Let's say input capture mode. I've used that before. I had a case where I have those let me pause it and I'm going to show you something. Okay, so what I was going to show you for input capture mode, this is what I used it for. I had a case where I have a couple of these controllers. Not this one. This is really expensive. But you know, you've all seen these controllers, and you press the knobs to go up or down or whatever, and they send out a signal to one of these guys. These are usually the receivers. Okay. And if you were to look, they don't really show the inside of it, but there's these little pins here. Maybe this one shows. Okay, see these pins? That's every line of those corresponds to one of the buttons or knobs on the controller. So I was controlling, let's say, this lever, moving it up and down. It sends a signal to the receiver on one of those pins, and I had those pins connected to my STM32, and I was using input capture mode to capture the signal that I was getting from that receiver. And that signal that it produces is nothing more than a servo signal, right? Because these are for model airplanes. They use servos. And when I had the lever that I was not touching the lever, this was the signal I was getting. And then when I pushed the lever all the way one way, I would get a 1 millisecond signal. And when I push it the lever the other way, I would get a 2 millisecond signal. So that's all it was. So to measure what value I was getting, I was using input capture mode. And so you're basically getting a value from 1 millisecond all the way up to 2 milliseconds, where 0 is basically right in the middle. The center of the waveform here is when you're not pressing anything. When see how it's centered? So if you press it all the way up, it would be, let's say, 2 milliseconds. If you press it all the way down, it would be 1 millisecond. And I had that, and I was reading it through the STM32 on the receiver, and I was using it to control something else. I think I was controlling a motor to have it go full speed forward or full speed reverse. So yeah, so that's one very useful case for input capture mode. Let's see what else we got. Then you have output compare. Output compare is a good mode to generate, I guess, certain times, certain delays, and because you can use interrupts with this. So what output compare does is it counts up to the counter is just counting up or down, whatever, and then you have a value, like let's say 500, and let's say it's counting up to 1,000. So when it gets up to 500, which is your compare value, then it outputs a signal or an interrupt or whatever it is, right? So you use that to generate things like delays or stuff like that. Then there's PWM. PWM, well, you guys know what that is, and you guys know what you can use that for. One pulse mode, I've also used it. One pulse mode, it's like a PWM. It outputs a signal, but it only does it one time. So for example, there was a time where I was using those sonic sensors that everybody knows. See, I'll show you guys. One of these guys, and they required, I think, a 10 millisecond pulse on the trigger pin. So what I did was I had one channel, and I would do a one pulse mode, and then I would do a 10 millisecond pulse, and then I would switch it to input capture mode, right? That's for example here. I had this. I could have done it separately, but I just had it all on the same pin, where I had it first as one pulse mode. I would do the 10 millisecond pulse, and then I would switch it to input capture and receive the signal from the sonic sensor to get the distance or whatever it is. So yeah, so those are some, I guess, use cases for those different modes. So let's look at the registers for the most part. Here also, you know what? Let's look at the PW. No, let's not even look at PWM. We'll look at PWM when I'm actually going to do the video on it. Let's just look at the registers, and we'll just get the timer going really fast and see what we can do with. So here's the control register. Here's the first control register, and here are some of the important things we're going to be using here. The bit 0, the direction bit, this CMS bit, and when we get to the PWM, we'll be using this bit. But for now, let's concern ourselves with just these two bits. The fourth bit here, direction, the counter used as a down counter or counter used as an up counter. So you can control whether it's counting up or if it's counting down. Okay, and then the 0th bit is just the enable bit that actually gets it going. So if we just look at here's some code that I have for you guys. So the first thing we're going to do is, obviously, when using any peripheral, you're going to enable your clock for that specific peripheral, and you're going to enable the whatever ports it needs. Now, you don't really need to enable the GPIO-B right now, because we're not going to output anything. We're just going to get at counting and play with the different modes. But once we get to actually doing the PWM, at that point, then we will definitely need to enable the port B register so that we can get the output here on our channel 4 for the PWM. But at the moment, you don't really need this. Again, the alternate function, you don't need it because that has to do with the pins. This is alternate function for, oh no, this is the alternate function. This is GPIO-A. This, I'm using it for my my print message, to print to the COM port, and I have a separate video for that if you guys want to see that for debugging. And that's what I'm going to be using to show you guys what the timer is doing, and as well as the logic analyzer to show you the signals that it's outputting. But I'll get to this when we do the PWM. Okay, so again, I'm configuring the pins here, but I don't need to do that right now because we're not going to output anything on the actual, no, I need that. We're not going to output anything on the actual pin, so we don't have to configure the pins as of right now. So really, to get your timer going, you just need these 3 lines right here, right? And we're going to set a prescaler and an auto reload. Now, what are these and what do they do? Okay, so if we go to the datasheet, we'll go to that prescaler register. Here's a timer, the register prescaler. So prescaler, here it is, and it's on the next page. It just divides the frequency of your clock, takes your clock frequency, and it divides it by this prescaler, right? Which is a number from 0 to 65535. So it's a 16-bit number. And all it's going to do is it's going to divide the clock that's feeding the timer. So, for example, your timer, or is it your timer? Let's say here we're using timer 4, which is on the APB1 bus. It's running at 72 megahertz. So we're going to divide that 72 megahertz by whatever values in the we put in there. And ultimately, we're doing this to get a specific frequency that we need. Okay, and then in our code, we also have something right into this ARR register. This is the auto reload register. So this takes whatever we got from here, whatever frequency we got, by dividing the microcontroller frequency, by dividing it by the prescaler. This divides it even more, because now the counter is only going to count up to this value. So let me explain what that looks like. So here's some little graphics I created for you guys. So first, I guess we can start with some of the math here. So we're going to take our peripheral clock, which is going to be our crystal or internal oscillator that we're using to drive our microcontroller. We're going to divide that by the prescaler, which can be from 0 to 65535. And then we're going to divide whatever that output by the auto reload register, and ultimately we'll have our timer frequency. So what does that look like? It looks like this. We have the peripheral clock divided by prescaler divided by the auto reload register timer frequency. Okay, algebraically speaking, that's nothing more than peripheral clock, this, divided by prescaler times that is that, right? The timer frequency. So in a more useful version, which we just take this and do regular algebra, you can take your peripheral clock and divide it by the desired frequency that you want, and then you'll get a value, and you just have to make sure that your prescaler and your ARR multiply to be that value. So if you want a frequency of whatever, let's say 2 megahertz or whatever, let's say it gives you a value of 10,000. Okay, so now you need to make these two multiplied to 10,000. So you can put 5,000 and then 2 here, right? Or you could put 2 here and then 5,000 over here. It doesn't matter. As long as they multiply to be 10,000, then you'll get your frequency that you want. So peripheral clock divided by the desired frequency, you'll get a certain value, and that value, you have to make sure these two multiply to be that value. Right? It's not that hard, and a lot of times you can just set this to 0, you know, to just not have it prescale it at all, and you can just, you know, use one of them to this has to be set to something, because this is what your counter is going to count up to. This is what your timer is counting up to, right? So you cannot divide the clock, but you have to count to something. This is the value your timer is counting up to. So let me show you another graphic that explains that a little bit better. Okay, so here's what's going on in your what's actually going on. So this is a register, which is right over here. This register is right here. So this register is basically, this is the heartbeat of your counter. This is that sounded terrible, babe. Anyways, this holds the value that the counter is counting. Your timer's counting, right? Because remember, a timer is nothing more than a counter. So this actually holds the value, the current value of the timer. And again, it's all 16 bits. Okay, so what's going on? Your timer is going to count up from 0 all the way up to whatever value is up in here. It's in this auto reload register, right? So here's your timer count, right? Here's the value. It's counting up. It's counting up. Once it reaches that auto reload register value, it's going to go back to 0. Then it's going to start counting up again. Go back to 0. Count up again. Go back to 0, and you get it. So that's why you have to have a value here. If you have a 0 here, if you have no value here, right, you're gonna get a flat line output. It's gonna be nothing, because this, you know what I mean, it's gonna count up to 0, go back to 0, 0, you know what I mean? So you have to put something here. You can't have the 0. This can be 0. You can have a prescaler of 0. That just means it's not gonna divide your clock. But you can't have an auto reload register of 0. Okay. So yeah. Now there's different modes of counting, and like I said before, if you look on the data sheet here, we go back to that control register 1. Remember this direction bit 4. You can actually set it as an up counter, which is what you see right here, right? This is what you see right here. It's counting up, and then it's overflowing back to 0, counting up. So that's an up counter. Or if you set that bit to 1, it'll be a down counter. And in that scenario, it's the same thing, but kind of I guess upside down. So now it's starting at the value that you have in your ARR register, and it's counting down to 0. When it gets to 0, it shoots back up instantly, obviously, to the ARR register, and then counts back to 0. Up, and then counts back to 0. Okay, so you can have it as a down counter also. Then there's I guess I forgot to highlight these bits right here. These bits right here, you have edge aligned mode, which is what we have right now, which is the default. They call it edge aligned mode. And when you get into PWM, you'll see why they call it that, and why they call these center align mode. So in center align mode, the counter counts up and then down instead of just down or up. So in center align mode, what you get is something that looks like this. Now your timer counter is going to count from 0 all the way up to your value that you have set, and it's going to count down. Count up and then down. Instead of going up and then shooting straight to 0, no, it's going to count gradually down to 0. So it looks like this. Okay. So let's see if we can observe all these behaviors in our actual code, or actually, I mean, on our here on our, where is it, the access port. Okay, so right now I have my microcontroller. It's running, And I have the Prescaler to 65,555. I have it set to the maximum value because anything, trust me, anything faster than this, watch, if I set it up to 100, I do this and we upload it, it's happening so fast you can't even tell what's going on because the frequency is just too fast. So I have it counting up to 6,000, and it's all I did was I put that maximum value in the Prescaler, and I have the auto reload register to 6,000. And again, in my while loop, all I'm doing is printing the timer count, which is the current value of the counter. So like I said, it's gonna go up to, take that away, it's gonna go up to that value. Oops, what did I do? It's gonna go up to this value. Oh gosh, my little file here got all messed up. Anyways, it's gonna go up to that value, and it's going to go right back to 0. So if you can observe that right here, 2,000, 3,000, 4,000, 5,000. It's getting up to 6,000, and then it's just going right back to 0 right after 6,000. There you go. See? So again, it's this kind of behavior. Now, what we can do is go to the code, and in this control register 1, right, all we did was enable, but we can add also, let's add this bit now, which is right here. Now let's this is a 0 currently, but let's change that bit to a 1 so it'll count down, right? So then it'll have the opposite behavior. So we can do time 1, control register 1, and we're looking for this bit right there. Okay, so now we have that bit activated, and we'll get this this sort of behavior. And did I upload it? I'm not sure. And there you go. See, it's counting down. It's gonna get down to 0, and then gonna jump back up to 6,000 and start counting down. Okay, so now excuse me, now let's go ahead and do the other now this right here where it's center aligned, and all we have to do for that is put a 1 into the 0th bit, not this 0th bit, but the 0th bit for this section. So this would be 0, this would be 1 for this section. So just put a 1 there, and we'll get center align mode. And since it's counting up and down, then this becomes irrelevant because, you know, it's going to count up and down, so it doesn't really matter what direction we put. So control register 1, what is it, CMS? Yeah, CMS. So we're going to put a 1 into the first bit. Oh no, this is right here. Into the first bit, which is bit 0. And now we should see it count up to 6,000 and down instead of resetting back to 0. So it's going down, and now it's going up. And then down, and then up. So now it has that this behavior that I showed you before, where it's going counting up, counting down, counting up, counting down. So that in its most basic form is our counter, and there's no PWM or anything here. We're just setting up the counter and getting it going. Now in this video that's gonna follow right after this, we're gonna jump from I'm gonna just cut this video off, and then I'm gonna start making the video for PWM. So it's gonna leave off right where this one ends. I mean, it's gonna start off right where this one ends. Okay, guys.